Assalamu alaikum. Welcome to lecture number 34 for the subject of software design and architecture. iTech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture, so students, basically from second last week we are actually discussing the software reuse landscape, where we actually discussed a model driven architecture in our last week, where we see what is actually a model driven engineering, and we see what are the different usage of model driven engineering, where we also see about the different milestones of how model driven architecture is actually developed by OMG organizations. And then we see comprehensively about what actually the model driven architecture, which is actually a reusability approach. And then we see about different adaptation status of model driven architecture, like we see how UML actually profile is underway. First of all, it's adopted the Corba, and then it moves towards the EJB, and then SOAP.NET frameworks, and then the UML 2.0, which is ultimately in process, where we see these different adoption statuses of model driven architecture. And then we see actually different types of model driven architecture, where we actually see computation independent model, platform independent model, and the platform specific model as well. And then the most important discussion towards model driven architecture transformations have been discussed very comprehensively with the help of example as well in very detail. And then we see multi-platform specific models as well. And then we see executable UMLs, what actually they are. And then we see the different features of executable UML in the model driven architecture. And then we also compare the more agile methods with model driven architecture as well. And then at the end of our last week lectures of model driven architecture, we also see different kind of benefits, issues, and challenges being provided by this model driven approach as well. And then at the end we also see some state of the art different model driven tools available for the community to practice this model driven architectural approach. And then we conclude our talk about the model driven reuse landscape in our last week lecture. So students, this is a recap about our last lecture, where we discussed about model driven approach, which is actually a software reuse approach, where we actually see how model driven architecture actually supports the reusability to its community. So student, this is a little bit recap about our last week lecture discussion. So let's formally start our today's lecture discussion. So students, what are the different objectives of our today's lecture discussion? So students, in this week we are actually moving towards another software reuse approach, which we actually named as aspect oriented programming. So basically, before I start toward the aspect oriented programming, I would like to give you a little bit historical backgrounds or some kind of foundations to give you an authentic argument why we are moving toward this aspect oriented programming. So providing you some kind of base, some kind of base or some kind of foundations or reasons behind why we are actually moving from object oriented to aspect oriented paradigms as well. So that's why I would like to give you a little bit some recap about functional programming and object oriented programming. So these two are the not new terms for you, but in this lecture the purpose is just to some repolish about the conceptual knowledge behind the functional programming and the object oriented programming. And the most important thing in this lecture, we will see how we are actually shifting from object oriented approach to aspect oriented approach. So this is the basic purpose of this lecture, to provide you the argument why we are thinking towards now aspect oriented approach as well. So this is the brief objective of our today's lecture discussion. So students, before I start my today's lecture discussion formally, Here is a diagram for software reuse landscape, which you also see in the last lecture, in last week's lecture, and in the second last week as well. So students, basically aspect oriented programming, model driven architecture, or software product line. So basically these are the software reuse approaches in terms of software architecture and design. So basically in our second last week we discussed about software product lines, how actually they support the software reusability to its community. And in the last week we see about model driven engineering, actually what is model driven engineering, and how model driven architecture provides supports to its community to achieve greater level of reusability in terms of architecture and design. And now in this week we are moving towards another reusability approach, which we known as aspect oriented programming. So it's our last approach towards software reusability landscape, which is aspect oriented programming. And software product line and model driven engineering already have been discussed. So now in this week our focus will be on aspect oriented programming, and where our main focus will be on aspect oriented architecture. So let's formally start our this week discussion about another reusability term, which we known as aspect oriented development. So students, before I start my discussion towards what is actually aspect oriented programming, I would like to give you some kind of base knowledge, or you can say some kind of arguments, or give you some kind of justifications why we actually need aspect oriented programming. So that's why I need to give you some kind of counter arguments about why we actually, or why the programmers community actually shifting from functional or object oriented programming to aspect oriented programming as well. So let's formally start. So basically, if I talk about a functional programming, here you can see in this diagram we have multiple functions. So basically this is a messy graph of different functions, how different functions can be achieved in a program, or in a, you can say in a project, or some deliverable product. So any deliverable product must contain multiple functions, where multiple functions will deliver some kind of functionality. So basically this functional programming, students, is a style of programming in which basic method of computation is actually around towards the application of functions to its arguments as well. So this functional programming, we can say, supports and encourages the functional style. So in functional programming, we actually divide a program into many functions to achieve some goal or some deliverable product, which we call a software or any organization project, etc. So in this we can say that there are number of functions that are actually interdependent and call each other to perform a specific task. So here you can see that the function of A actually dependent on the function of B and E, and the function of C are actually dependent on the other two functions. Here you can see all of these functions are actually interdependent, and they call each other to perform a specific task. So this functional programming is not a new programming technique, it's an old one technique, and you can say it's a traditional approach towards a programming languages. So my question or argument is about what kind of problem is actually we facing in this functional programming. So like I say, students, if we have a complex design, then we have a lot of functions. So that's why a number of interdependencies between them, and their graph become messy. And in this diagram you can see that we have just only 6 functions, but normally in large applications or medium sized projects, we have a large number of interdependent functions which are actually dependent on each other, and they are actually calling each other to perform a specific task. So that's why this graph which we see is actually become very messy. So their code also become more complex in large project at execution time. So it actually, this functional programming actually takes a large amount of time. So if there are several number of functions to execute, it require a lot of time. So these are the different kind of limitations which are actually being faced by the functional programming approaches as well. So that's why to achieve a greater level of other reusability approaches, some kind of modularity, inheritance type of features, uh, was the community looking for. So that's why they are shifting from object oriented programming. So here we move towards the object oriented programming. So all of you already have been studied this object oriented subject in your third semester or in somewhere in your degree as well, because you are senior semester student. So basically this object oriented programming providing us a way so that we can think like they are working with real life entities, like with distinct and independent existence of objects as well. So in real life, students, we can say like people have knowledge and can do various type of works. So this object oriented programming, where we have objects have different kind of fields to store knowledge and state data and can do various works through its methods. So here you can see that in this object oriented programming paradigms, uh, while we'll start working in this object oriented programming, which is actually provide as a organized model to work around objects rather than function or some actions. So and data, and we focus on data rather than the logic. So it is basically this object oriented is basically provide as a paradigm to design a program using objects and classes. So it is this object oriented programming, as you know, is a collection of objects which you can say actually interacts to solve a problem or a specific task. So basically this approach is actually contains a set of objects rather than an action, as we see in the function oriented approach. So this approach enhance code reusability, and it also provides some other kind of principles like inheritance, polymorphism, etc. I am not here to discussing about the advantages or some kind of functionalities of have been provided by this object oriented programming, but I am just trying to provide you some kind of foundations why we are shifting toward aspect oriented programming. So students, if you look in this diagram you can see that actually we have three kind of objects: object A, object B, and object C, where we have their data members, which we also call the member variables, and their procedures, which we also call the data methods. So member variables means your data members and procedures mean your data methods. So similarly in multiple objects, like object A, in object B, and in object C, which actually contains the data member and the data method. So what kind of problems in object oriented programming actually being faced by the this object oriented community? Actually this is not a suitable for common procedure, like where we have a common data methods. This is actually not a suitable programming language. Like we can say like not all of the programs can be classified into one object. For example, like if I say, if we have a log message in every object, and then we insert repetitively a code in every object, so that is not a good design. So it becomes more complex in this case. So that's why object oriented programming face some kind of limitations as well. So if you see more technically, if you see in this diagram, actually we have three objects: object A, object B, and object C. If you look into the functions, we have a log message data method in object A, and log message same method in object B, and the same method of log message in object C. So in these kind of situations, this object oriented programming is not is a suitable approach, where we have a common procedures across multiple objects. So you can say like not all of the programs can be classified into the object. For example, in this diagram, as you see, if we have a log message in every object like object A, object B, and object C, we insert repetitively a code in every object. So that is not a good design, so it become more complex. So how will we will refine this code, you will see in this slide. So how we will actually refine this code, where we have multiple where we have common procedures across multiple objects. So and we actually refine this code by separating objects, like in object A, B, and C. As you see, we have a log function. So we actually take a separate object for it, like named as logger. In the logger, we actually separate this log message object for the rest of three objects: object A, object B, and object C. and you can say that then other objects have this separate object reference into their code. The most important aspect is logger, in the logger object where we have a log message data method, then other objects have this separate object reference into their code as well. So the new object we can say could be the parent class, and it could be inherited into the other objects. So in this slide actually I'm telling us about the how we can resolve the problem of separating about common procedures or data methods. So it's pretty straightforward because all of you are already have been studied the notions behind object oriented programming. Actually I am providing you the arguments why the community of developers actually thinking towards aspect oriented programming approach. So there are different problems in separating these objects also exist. What kind of problems? Let's discuss in more detail. Like we can say there are too many relationship to cross-cutting objects, like code is still required in all methods, so we have to write the code of the separate object into all the objects as well. So we can say because all of the objects will also be provided in different objects as well. So we can say there is not a good graph. We can see it becomes a messy graph. So the program should also be messy, like when there is many other cross-cutting objects are also existing. So we cannot all be changed at once in this object oriented programming. So these are the different reasons or problems why the community is actually thinking towards some kind of other approach. So these are the different problems actually was being faced by the object oriented community. So these problems are also discussed here, multiple relationships or many relationships to different cross-cutting objects. Code is also required in all the methods, as well as you see in the previous slides where we see how we will refine our code by separating the object, and then you also have to write the code for each separate object into all the objects with the help of some reference into their code as well, as we discussed earlier. So this approach also is a not a provide us a not a good graph, so it also become a very messy or huge mashup exist in this approach. Like when there is many cross-cutting objects exist, so it also become a problematic approach as well. So in this object oriented programming where we have multiple objects and we need to separate object from all of, we need to refine this code by separating objects. So we cannot all be changed at once is also another limitations by this object oriented approach. So these are the different reasons which I explained in your last 5 to 6 slides from functional programming to object oriented programming. So what kind of limitations are actually existing? So these are the different reasons why we need to develop a new programming approach. Not we can say a new programming approach, so we can say it's a so it's a little bit modifications of object oriented programming. So it is almost look like an object oriented programming named as aspect oriented programming. So these are the different problems in separating the object. So that's why we are actually looking for some approach which we call an aspect oriented programming. So these are the different foundations about why we need aspect oriented programming. So let's start the discussion of aspect oriented programming. So what is aspect oriented programming? So before I start this aspect oriented programming, I would like to share with you a little bit history about aspect oriented programming. Like this is actually developed in the, you can say, in the in the 90s, or it actually released in the early 2000. So it actually oriented programming is actually used in large projects, like first released as aspect j is provided, and other frameworks of java are also provided, like java spring framework is also provided. Microsoft transaction server is also a very famous one. So this is the history about the aspect oriented programming, which is actually uh, provided by the MIT Technology Review. So what is actually the notion behind this aspect oriented programming? So this aspect oriented programming, students, I must say about this is a actually a new concept which was actually developed to overcome the shortcomings which we've being faced in object oriented programming. So there is not too much there is not a large difference between object oriented or an aspect oriented programming. So in object oriented programming we are actually deal with objects, and in this aspect oriented programming actually we concern itself with aspects as well. So in this aspect oriented approach, we can must say is not a we can say aspect oriented approach is not a feature, like it is just a model of programming itself. This approach actually supports a modularity supports or increases the modularity by allowing the separation of concern, which we also call a cross cutting concern, how to separate different concern though. So the separation of concern is also an important aspect of this aspect oriented programming. So in this aspect oriented programming, like a party we can say a particular part or feature of something we call aspect. In aspect oriented programming, the meaning of aspect is actually, you can say, a part or some feature of something is called aspect. So in this aspect oriented paradigm, actually it breaks down the program logic into distinct different parts which we called concerns. And now this approach actually allows the programmer to handle different cross-cutting concerns like as separate single entity. So this approach, like for example we can say, whenever a method is executed you can add extra functionality before or either after the execution methods. So this aspect oriented programming students, we can say, our aspect oriented programming is actually different from object oriented programming in number of ways. Like aspects are different from classes, like aspects are different than classes because these aspects can additionally include as members as well, like advice, point cards, which we will discuss later in our lecture as well. And these aspect oriented programming do not have constructor, or we can say a finalizer, and they cannot be created with a new operator. So it also, aspect oriented programming also different from the classes, like different privileges aspects can access private members of other types as well, which we have not seen in this object oriented approach. So in here we actually discussed about the different paradigms of aspect oriented programming, which is basically an approach to software development which is actually intended to address this problem as with separation of concerns as we discussed. And you must say it actually it actually makes the program easier to maintain, and it actually increases the reusability as well. So we can say, like in most large systems, students, the relationship between requirements and program components are very complex. So a single requirement may be implemented like by a number of component, and this each component may include element of several requirements. So in industry, if you see, this actually means that implementing a change to the requirements may involve a understanding and change several components. So alternatively, if we say, a component may provide some core functionality, but it also include code which implements several system requirements. So even when there appears to be significant reuse potential, so it may be expensive to reuse such components. So reuse may involve like modifying them to remove extra code that is not associated with the core functionality of the component. So that's why aspect oriented is an approach to software development which is intended to address this problem. So the main concern of this aspect oriented approach is the separation of concerns. Separation of concern is basically a key principle of software design and implementation. Separation of concern actually means that you should organize your software so that each element in the program, like class, methods, or procedure, does not think and one thing only. So you can then focus on the element without like regard for the other element in the program. So you can understand each part of the program by knowing its concern. so without knowing the need to understand other elements. So whenever the changes are required, they are actually localized to a small number of elements. So ultimately, the we can say the this aspect oriented programming increase the modularity, so it's provided as a greater level of reusability as well. So this is a little bit introduction about aspect oriented programming. So student, till here over this lecture is comes to an end. So in this lecture I provide you the foundation behind why we are shifting from functional programming to object oriented programming, and what kind of limitations are actually being faced by object oriented community, and why we are shifting from object oriented programming paradigms to aspect oriented programming. I provide you some kind of examples and some kind of foundations as well. What are the actually foundation, or some kind of actually behind the pillars or foundation behind the adaptation of aspect oriented programming. So the main problem is in the separation of concern, and the issues which are we are being faced in object oriented programming is actually resolved in this aspect oriented programming. So aspect oriented programming, I am concluding here, I am concluding my lecture here. Aspect oriented programming, we can say, is not a feature, it is just a model of programming itself, which actually aims to increase modularity by allowing the separation of cross-cutting concerns. So in coming lecture we will discuss in more detail about aspect oriented programming. So students, till here our lecture number 34 is ended.